is less than the key, so the frequency will set. We also make the one function for set frequency, and our note frequency are the 8 notes. And after releasing the switch, SysTick will stop, and port data of the that port will be set to 0. Now the DAC initialization. In DAC initialization, we enable the direction register, that is we are taking output, so we configure it as a 0 hexadecimal FF, we are configuring port B from 0 to 7, and for digital enable we configure it as FF. And this is the first we set the clock and give the direction for output, and this is the digital enable for functionality to digitally enable. And then the read switch, in this we are using port E and port F as a input, so we set the registers for direction, digital enable and pull up register, because we are using as a input, so we set the pull up register as a 0F. Why 0F? Because we are using list 4 bit, like PF0, PF1, PF2, PF3, so that's why we make it 0F. And similarly for port E also we did. In read switch, we took two variables, unsigned variable, last key and stable key. Last key like previous key what was pressed, and stable key what new key, like stable key after we use this logic for debouncing, if we press the key, then it will it can detect the multiple input, so we are stabilizing that key press, so for that we are using a stable key. Now this is the iteration. This loop will run 5 times, and this is the data of port F, which will go on this variable, and data of port E and F will go this variable. So now if stable key is 0, so that data will go on to this variable. Now if we press the key, this logic will detect the switch, which switch is pressed. So after that it will return to next switch. Return only when status change, like if last key and stable key is not equal to, so this stable key and last key both are equal, and return to stable key. Otherwise otherwise return to 8. It means no new press key detected. In above code, it's showing that key is pressed, and here like no key is pressed, so it will return to 8. This function we use for the reload the SysTick, reload our frequency. This is the formula to reload the value in SysTick timer. This is the initialization of SysTick timer. Here is the NVIC status control register. First we disable all the values, and then reload the value whatever we set in above function, and make the current value 0. SysTick handler, it will handle the index what we make in lookup table, like it will start from 0 and goes to 31 and again wrap around to 0. This is the delay function. This function will create 1 millisecond delay, and this is the standard calculation. So these are the 8 switches, and here R2R ladder, and this is the low pass circuit, low pass RC filter. So whenever we press the switch, this will generate a wave. Like this will go to this is the input for this input will go to microcontroller like PF naught, and this will create the output through the PB port. That PB port will input for R2R ladder, and R2R ladder output will go to RC filter, RC low pass filter, and after filtering the noise, that output will go to buzzer. Now you can see the demonstration. Thank you. With this, we are concluding the demo. Thank you.